Okay, so in problem 4, it's first telling us to pick a number, subtract 5, multiply the answer by 4, divide the answer by 2, and subtract 2 times the original number. So first it's telling us to A, use inductive reasoning to find a rule that relates the number selected to the final answer. And B, use deductive reasoning to prove your conjecture. So inductive reasoning is moving from specific examples to try to figure out a general rule. So when we're going to start with specific examples, we're actually just going to pick whatever number we want. And we can do this a number of times until we think we've figured out the pattern. Okay? But we haven't proven anything. We've just figured out a pattern using specific examples. That's inductive reasoning. We're going to induce, the rule from the examples. And then once in part B, in deductive reasoning, we're going to say, okay, now that I've figured out the rule, I'm actually going to show that it's true, not just for the examples that I picked, but for no matter what number that I pick. No matter what number I pick, this rule is going to be true. Okay, so let's start with part A. So let's pick some numbers. I'll make some. Okay, let's start with 0. Okay, so let's subtract 5. So I'm just going to kind of show the progression. So I subtract 5 and I get -5. Multiply the answer by 4. So -5 times 4 is -20. Divide the answer by 2. So I'm going to get -10. And subtract 2 times the original number. So the original number was 0. 2 times 0 is 0. So subtracting 0, I get -10. Okay, let's pick another number. Let's say 3. Okay. I'm going to take my 3, I'm going to subtract 5. All right, -2. Multiply the answer by 4, so that's going to give me -8. Divide it by 2, -4. Subtract 2 times the original number. So in this case, the original number was 3. 2 times 3 is 6, so what I'm subtracting is 6. So -4 minus 6 takes me to -10. Let's pick another number. Let's pick, 50. All right, 50 minus 5 is going to be 45. 45 times 4 is going to be 180. Divide that by 2 is 90. And then subtract 2 times the original. So my original was 50. So 2 times 50 is 100, so I'm going to subtract 100. So 90 minus 100 is -10. Now you might be starting to see a pattern that it always comes out to be -10. So that's inductive reasoning. Inductive reasoning is picking numbers and noticing a pattern. You're looking at specific examples until you get to the point that you can notice a pattern. So that's really part A. Part A is getting to the point where you can say, it really to me looks like it's always going to come out to be -10. I wonder why that's true. Okay, but figuring out the pattern is part A, the inductive reasoning. Now part B is saying, well, okay, you showed that it's true for 0, 3, and 50, but how do you know that it's always true? So part B is going to show that it's true no matter what you choose. Okay, so now kind of going on to part B. We want to have something that could represent any possible number that I could pick. Not necessarily 0, not necessarily 3, not necessarily 50, but any possible number. So let's call it x. Okay? And now what happens to x when you subtract 5? Well, you get x minus 5. And then what happens to x minus 5 when you multiply it by 4? Well, you get 4 times x minus 5. And then let's divide that by 2, just following what's happening in the problem. You get 4 times x minus 5 divided by 2. And now subtract 2 times the original number. Well, what's the original number? The original number, we don't know what it was, right? It wasn't 0, it wasn't 3, it wasn't 50. It's x. X is representing any possible original number. So subtracting 2 times the original number is going to be minus 2x. So this is kind of what's happening to our x. But notice, in part A, we notice the pattern that it always seemed to come out to be -10. And that's what we're trying to show in part B. So we're trying to show that this, no matter what you plug in for x, is actually going to always come out to be -10. So the way that we show that this is always going to come out to be -10 is we have to simplify it a little bit. So the first thing I'm going to do, there's a couple ways to do this. You could distribute first, but what I'm going to decide to do is first notice that this 4 divided by 2 is just going to be 2. Okay, so I end up with 2, and then I still have my x minus 5 minus 2. Okay, now I'm going to distribute. Okay, so like this. End up with 2x, right, that's 2 times x, minus 10, right, that's 2 times negative 5, minus 2x. But then notice here, right, this 2x cancels with this 2x, and all I'm left with is negative 10. So what I showed is that no matter what x was, if I took my x, I subtracted 5, I multiplied 4, I divided by 2, and then I subtracted 2x, the thing that I'm left with actually simplifies down to negative 10. So I always end up with negative 10. So if you do this problem and your answers for A and B don't match, then go back and check your work. Because what you proved in part B is that it's always going to come out to be negative 10 regardless of what you did in step A. I mean, regardless of not what you did, but regardless of what points, what numbers you chose for your x. So it's possible you made a mistake in part A when you were plugging things in, and it's also possible, probably more likely, that you made a mistake with your algebra in part B. But you very much should end up with the same solution for A and B. Just in A, you're noticing the pattern, and in B, you're proving that the pattern is true for everything.